Welcome to Qlucore Omics Explorer. In this tutorial, we will introduce the program and show some of the basic functionality to help get you started in the best way. We will introduce the user interface, work with different types of plots and visualizations, and show how to set up a statistical test and save the results. It will not include loading of a dataset. For more information on that, we have several tutorials to learn how to load different data types available on our website. To quickly get started, we load the Qlucore test dataset from the example files in the Help menu. The first plot is a sample PCA plot, and each sphere in the plot corresponds to a sample. This dataset has 24 samples and 50 variables, and this is displayed in the information bar at the bottom left of the program. The toolbox controls the functions of the mouse. The default selection is Move. Move the mouse pointer to a plot. Now press the left mouse button and move the mouse and see that the PCA plot rotates. Selecting the Label Mouse tool will allow you to label one sample by clicking on it. To select multiple items, make sure the multi-check box is checked in the toolbox. By circling multiple samples clockwise, you will now be able to label all circled samples. A counterclockwise selection will undo the labeling. There are many options for the mouse tool. The Info Mouse tool will bring up a sample annotation information about a sample. And this brings us to the Sample tab. In this part of the user interface, all information about samples and sample annotations from the data set is available. In this data set, there are 11 sample annotations: age, sample ID, sex, time point, treatment, etc. The sample annotations contain information describing the samples or grouping the samples. For more information about annotations, we have specific video tutorials covering the import of both sample and variable annotations. The next tab is the Variable tab. Variables can be of many types, for instance genes, proteins, or metabolites. In this data set, the variables are genes. By default, two lists are open: the search list and the active variable list. The search list includes information from a search. The active variable list in bold includes the remaining variables in a data set after any filtering and selection have been applied. At this point, we have not applied any filters or selections, and hence the list includes all 50 genes in the data set. The variables list can be populated with information columns. These can be either variable annotations or calculated values. As an example, we now add the symbol column by selecting the column selector icon. Before we start the analysis of this data, we will look at some of the tabs up here to the right. Here we have several tabs with useful functionality, among them Data, Method, Options, and View. The Data tab provides functionality for basic calculations on the dataset. Examples are applying pre-filters or log transformation of the data prior to starting the analysis. In the Method tab, you can change to many different plots. As an example, we change to a heat map. This plot can be configured in many different ways in the View tab. The auto buttons in the Size section can be used to expand the heat map and show all samples and all variables. In the Label section, we can change the sample and variable labels. Here we change the variable label to symbol. In the Ordering section, we can change the order of the samples and the variables. Here we change the order of the samples by applying hierarchical clustering. We cluster samples as well as variables. In the Color section, we can color by one or many sample annotations. And we can also color the variables in different ways. For more plot settings, we can either double-click in the plot or select the Show button in the Plot Settings section. Here we can change font sizes, highlight missing values, and also change the colors of the heat map. By double-clicking in a color box, you can select a color of your choice. By pressing the All button in the Method tab, you can see all available plot types that you can select to work with. Now we will move to the Statistical Analysis support and set up a statistical test. We will set up a test to find the variables that best discriminate the three groups defined by the sample annotation treatment for patients after treatment. We will work with two synchronized plots, a sample PCA plot and a heat map side by side. Right-click in the heat map plot to get a pop-up where you can select a new synchronized plot. The other plot is now in the background. You can shift between plots, and you can also select to show them side by side. To do so, right-click in the plot and select Tile. Color the new PCA plot according to the annotation treatment. If you want to change a color, just double-click in the color box that you want to change. We now see all 24 samples divided into 3 treatment groups. To focus on only the post-treatment samples, we go to the Sample tab and select Annotation Time Point. Here we uncheck the group Pre-treatment. This means that we are now only working with the remaining 12 active samples, the post-treatment group. Note that these samples disappear from both the PCA plot and the heat map. To move forward and set up the test, find your statistics window. If it's not open, click this icon in the Launch section. Now, select the filter by multi-group comparison on treatment. The multi-group comparison is an ANOVA test, and this statistical method is well suited to find the discriminating variables between multiple groups. Qlucore Omics Explorer includes several statistical methods and a framework that allows for advanced statistical tests. The program also includes an extended statistical mode that enables users to write their own statistical test. In this demo, we use the inbuilt methods. To see how the groups are structured, we have the sample annotation visible in the Sample tab. There are 4 samples in the placebo group, 4 in group drug 1, and 4 in group drug 2, giving a total of 12 samples. To find the most discriminating variables, select a cutoff in the statistics window. Normally, it is wise to use the Q value since it includes correction if the dataset includes many variables. Q value is the same as false discovery rate. Select, for instance, 0.05 and press Enter. Both plots are instantly updated, and in the left corner, it is shown that there are 11 genes that meet this criterion. These 11 genes are shown in the heat map. The corresponding p-value is shown in the left spin box. Changing the p-value cutoff slider will adjust the settings and the number of variables matching the criteria. Try it and note that the plots are updated. When you start to use the program, you will see that it works just as fast on your datasets. The sample PCA plot also clearly shows how the samples are grouped into 3 main groups. Using Move to rotate the plot can provide better views. Export the plot by right-clicking and selecting Export Image. The genes are collected in the active variable list that we looked at earlier. Let's also add the Q value as a column. Make a copy of the result captured in the variable list and rename the list. Export the list to save the results. We select to include the annotations in the exported list. To summarize, with the example data set, we have introduced the user interface, visualized the data using different plot types, performed a statistical test, and lastly exported both an image and the results of the statistical test in a list. For further analysis support, there are more video tutorials on our website. If you have any questions, please don't hesitate to contact us. Thank you for watching, and good luck with your analysis.